I'm so glad you didn't call me the expert in this field. Although I've worked in the nuclear industry about 13 years now, I pulled this presentation together with two of my colleagues, who very quickly, when I told them what the date of the presentation would be, was suddenly not available. I wonder why. So I very promptly said, hubby, you're good at sampling. Keith, you're very, very good at analysis. So any difficult questions, guess what? However, the reason I am doing this is because as part of my role, I do tend to sit through a lot of project kick-off meetings and do start to get to understand very clearly what a lot of your issues are when you're out on site, and then take it back to the lab and hear all the issues that they have with what we're proposing. So hopefully I'll be able to pass some of that insight on to yourselves. We try, where possible, obviously, to use NICOP as our best guidance, and it seems to be the only real code of conduct or best practice document that's out there. But in fairness, it isn't always as in-depth, maybe, as we would like to hope. So from our perspective, I think one of the things we would like to see maybe NPL do is maybe take this document and make it into a better guidance for sampling teams. And as I go through, hopefully you'll understand why. One of the things that, oops, this is not moving. Now, we did say that there would be a computer crash at this point. Hang on then, let's try that one again. Yay. One of the things that I do try to promote when I'm going around the sites is sort of more stakeholder engagement. I think it's very clear throughout the industry and even as AMEC or even as the labs, which is a very, very sort of small part of AMEC, it's very easy to work in our own little silos. So you're planning a project out on your sites, you know what your problems are, you'll have a rough idea of what you're trying to achieve, you'll go out, you'll take your samples, they might not necessarily be fit for purpose, and then you'll send them to labs and we just kind of go, oh dear, what on earth are you trying to achieve with these? What are we supposed to do with these? Etc. So what we're trying to promote here really is the dialogue from the very start of the project, so we get a full understanding of what you're trying to achieve, what your waste routes are, how representative the samples that you're going to take and that we finally get round to analysing are going to be, and therefore the results that you get at the end actually have some sort of meaning. And I think we've all been in situations where you've been provided with a bunch of data and you kind of say, but that isn't really representative of what I am trying to do at this back end. So what we're trying to do is promote better communications to provide, to sort of prevent that happening, ultimately save yourself some money. Julian asked me to cover three areas, DQO, the sampling and the analysis and the issues that are related with each. And I have to thank Steve Wilcox for the first few slides of this presentation, and actually going through them yesterday, I was very close to actually moving this to the back end, because I actually see this as a reasonable solution to a lot of the problems that we have. Now, the DQO process, the diagrams here show the sort of visual sampling plans that you can get out of this process, and how it can then highlight some of your hotspots and where you should be taking samples, etc., for any of you that don't really know how this process works. The process involves three phases. The planning phase, implementation, which is your sampling and your analysis, assessing the data that you get from the analysis, and then kind of deciding how you move forward from there. You may have enough data, which then allows you to consign your waste, or to report to the EA, or whatever you're actually using this data for. The idea is that it's systematic planning. It takes into account your historic data. It takes into account maybe desktop studies and stuff that you've done in the past. It's a statistical approach to kind of say, okay, this is where you need to take the samples. This is roughly how many samples you need to take. You do that analysis, you take the samples, you get your analysis done, and then you put your data back in, and it gives you a full kind of auditable chain to that whole process. It takes into account 7 steps, which as you can read yourselves, and as I've kind of explained already. And basically, it helps you to minimize, if you like, the amount of samples that you take. It helps you to only collect the data that you need, and it tries to prevent you ending up with something that you can't use in the end. And obviously you've got the visual sampling plans, etc., that support all of that scenarios. So in essence, if you get the design right at the front, you can allocate your resources to that, and you can start to minimize the uncertainty that you've got. So it's a fairly defensible technique. Now, I'm very aware that a lot of sites are already maybe doing this in part. And one of the things that we've discovered as issues with the DQO, I'm not saying it's perfect by any shape of the imagination, is that it can be quite costly to take all of this data, all this man-hour time, to pull all this information together up front. And then a lot of people will have the impression that it comes out with a random number generator of, say, an average 53 samples per building. So there has to be an element of common sense with what you're looking at. And if you don't stick with the process all the way through, it can actually become pretty meaningless in the end. And I think, you know, if you're going to take on DQO, you do need to follow it through. You need to put the resources available to actually do the process in full. And I think that was the one sort of issue that we found with it, is not very good if you do it in part. Now, in fairness, Steve Wilcox is one of our trainers, so trying to get out of him what the issues with the course or with the system was quite hard, because of course as a course trainer it's wonderful. But that seemed to be the main sort of conclusions that we'd drawn out of the process. But in essence, it should help you come up with a more defensible approach. So we're going through this. The implementation phase is basically your sample collection, making sure your packaging, etc. is right, making sure that you've got the right transport, you're getting the analysis, and you're doing the reporting. The back-end phase, which again seems to quite often be neglected, even within the training. People say, well, we want the DQA bit, but we don't really need the DQA bit. But to be honest, one isn't particularly good without the other. Once you've got the data, you've got to know what to do with that data, how it relates to the building that you've decommissioned, the site clear-up that you're doing. So one without the other is pretty meaningless, in fairness. So it goes through, you know, it will review the sampling design that you've had. It will take into account the analysis data that you've got. It will verify the assumptions that you've made, and it will draw conclusions from that data. So kind of one without the other, as you can see, really doesn't make a lot of sense. But unfortunately, quite often, one doesn't tend to go with the other. It tends to be our findings, and certainly tends to be the feedback that we get during the training courses that we've done. So sampling issues. Well, I feel like I'm telling you guys how to suck eggs, because who am I to tell you guys what the issues are? You're very, very aware. So I'm going to try and summarize these quite simply. The planning, which we've already kind of mentioned within DQO, is obviously very, very important. Understanding what the sample size is that you need in order to get a representative result out the back end is very, very important. And one of the things that we certainly find as a lab is that we can end up with a couple of grams of something and expect to come out with some meaningful result that's probably come out of so many 100 tons of sludge in a tank. It does kind of beg the question, how representative is that? So within the part of that planning, it really is a case of, you know, making sure that you're communicating with your lab at that point, trying to understand what the sample forms are that you're going to be taking, understanding what the site is that you're going to attend, whether it's manual sampling, whether it's remote sampling that you're going to be taking, and what are the issues that you're going to be having with that. PPE requirements, silly as it sounds, sample containers. If you're putting chemical samples with chemical contamination into plastic pots, you're going to get contamination from your plastic pots. So, you know, some of these very, very basic, very, very simple things are quite often overlooked when you're out there on the site, chucking it down with rain, and you know, you're trying to get these samples as quickly as possible so you can get back in the warm. Paperwork, is the plan sensible? It's very easy to get your DQO process. It says to go into that building and take loads and loads of samples, but oops a dear, they've asked you to take 20 samples out of your pane of glass within that building. You know, how realistic is it? So to make sure that the plan that you've got is sensible. To make sure that all the consignment paperwork is correct. And from my perspective, make sure that it doesn't overestimate to the extreme, because quite often they do overestimate just for transport purposes, and it can cause major problems when it gets back to the laboratory, if it ever actually makes the laboratory in the first instance. Make sure that the risks that you've got are adequately assessed, method statements are in place, permits are in place, etc. Briefings. It's very easy to assume that the guys that you're going to take on site actually know what you're going to do and why. But quite often we're finding when we're using contractors on sites working with ourselves, they may be highly skilled in the piece of sampling tool that they're going to use, the drill bits that they've got, but they don't necessarily understand why they're taking those samples, what they're going to be used for. So they'll take a bunch of samples, they'll stick them in the bag, they don't label them, or if they do, they'll maybe put 1, 2, 3, 4, 5, but they won't say where they've come from, why that area is of specific importance, etc. They get sent to the labs, we're like, okay, great, what am I supposed to do with this? And you can see how the scenarios kind of go from there. So there really does seem to be a lack of training for some of the sampling folk that we're actually receiving samples for, and certainly some of the contractors that we have worked with in the past. So make sure right at the start of the project that you've had that task-specific talks. Make sure you've had toolbox talks. It doesn't necessarily have to just be at the start. Throughout the project to make sure that it'll always run smoothly. And make sure that they are properly supervised at the work face. Don't just assume that because you've told them what to do that they're actually going to go away and do it as you've asked them to. Human error can tend to make a terrible problem on occasions. So generally, sampling isn't that technical, or so I'm told. I didn't write these slides, by the way. This is Matt, my second guy who did a runner. But sample preservation and storage is absolutely critical, and you know, make sure that you have got the right sort of containers. Again, we supply aluminium foil bags for things like tritium. Because you put a bunch of tritium samples together in a box, the migration of the tritium throughout, you'll generally end up with everything giving you the same results, purely because of the way that they've been transported. So again, you know, these things do need to be taken into account. We generally, because we've been bashing our guys quite nicely, now start to get samples in forms that we can easily handle. So again, if they can get it into shavings, scrapings, you know, scabbling dust, etc., so stuff that's very, very easily to be prepped in the lab, you know, obviously that's ideal, but we know that it isn't always the norm, and it's actually very rarely the norm. But again, making sure that the samples that you're able to get can be easily handled. Not always as easy, though, as they've nicely said, and they've said, okay, sometimes you do need to use remote operating vehicles, and these are some of the typical ones that we've actually got within AMEC that we use. They can get into places and confined spaces where maybe people can't get, but you still need to get that that inevitable sample. Those constraints, not only an issue within sampling, but certainly can be within the analysis. So again, it's really understanding all this stuff up front before you actually get in to do the job. Make sure that everything is fit for purpose. Really, we generated these slides in the hope of sort of get you thinking for this afternoon. The sort of areas where we kind of felt that we maybe need to think about. Maybe we take it for granted, but as we've experienced, you know, we'll do it all the time, but the guys that we're going to be working with necessarily don't. And therefore, what is there in place to help them to block that gap? So we then went on to kind of the good samples. This one's quite nice. You know, there's a few chunks. We can very easily do something with this in the lab. It's representable of the area of contamination. We've got homogeneous materials here. In fairness, that's probably actually gone through our grinder, but generally it's homogeneous. And to make sure that there's enough material to actually carry out the analysis. The last thing you want to do if you're working in confined spaces, high active areas, where it's going to cost you an absolute fortune with your ROVs to get in there, take the samples, decontaminate everything when you come out, is have to go back because we've gone, do you know what, you haven't given us enough sample to do anything with, whether that be for gamma spectrometry, whether that be for full analytical spectrometry. The bad. Well, we just thought these were really good, and I do apologise if anybody here recognises their samples. It wasn't intentional. Julie, next time give us the notice of who's coming in advance. But, you know, these are sort of typical examples of, you know, is this one sample or is it several? If it's one sample, fine. If it's several samples, they're all cross-contaminated. One's rolling against the other. What was the point? You're now going to have to go back and take all of those again. Similarly with this, you know, again, is it one or is it several? Down the bottom here, each of these were individual samples, and as you can see, they're all different layers. So you've got solvents, you've got oils, etc. What exactly are you trying to achieve with that sample? Do we actually have enough to do anything with? Quite often where they come out in separated sections like this, we have to take the top layer off and analyse it separately, take the next layer off and analyse that separately. As you can see, there's not a lot of volume there, so by the time we actually start doing the analysis, in reality, can we do anything with it? Or an even more typical is, here's a great big sheet of steel, like this, on a wonderful fingerprint. Well, okay, well, what am I supposed to do with this? Do you want surface contamination? Are you wanting the whole thing chopped up and made into some sort of, you know, proper job? It really does depend on what you're trying to do. Again, the ugly, similar sort of scenarios, you can see they're just really typical types of samples. But again, if you look at this one on the top right, in essence, it's several samples in one. You've got plastics, you've got copper, it's all different types of wire, but we'd have to separate them out. So again, it's what are you trying to achieve? So again, bouncing onto the analysis and reporting, how we approach it as a lab very much depends on what your endpoint is, what your waste route is. The LLWR will have a totally different fingerprint to maybe surveying a contaminated land site, but quite often we'll just get the same fingerprint. Oh yeah, I just need radiochemical analysis. Great. It can cost you a fortune, or it can be as minimal as you like. So again, forgive me, but I was asked to highlight the issues. So quite often, you know, you need that expert advice in front. When does it go wrong? Well, quite often, again, with the sampling team, we quite often find that they forget to decontaminate the sampling tools between taking samples. So again, how real are the samples that you've then taken? How real are those results going to be when you get the back end? We've already covered containers and preservation. Again, sampling program, has it been designed right? Was it done in isolation? Were we all fully aware of what needed to be done? Weather, inaccessibility, site issues, etc. will always be there. Transit, of course, we quite often get breakages, losses. In fact, it's not generally the courier's fault, it's bad packaging of the samples themselves. Paperwork can often be lost or not supplied, or it's been put in with a water sample, the water sample's leaked and it's totally made it illegible. They're just very, very simple things, but can cause real problems, real delays our end. And obviously in the lab, we need to make sure that we're not cross-contaminating your samples when we receive them. We need to make sure that the analysis we provide you with is right. And some of the matrices we receive, in fairness, can be really a real pain, to be honest. You can come up with random numbers, and I'll show you that later. And again, because there is a lack of reference materials, there isn't anything to kind of guide our own results by, in a sense, so we end up doing more and more repeats, but it becomes more and more costly. Data handling and transcription errors, of course. This was really just it was one of Keith's slides, in fairness. I'm going to say from this point, I'm going to blame Keith. But it was to explain that the type of way that the samples are processed through the labs. We don't just get them in, stick them on a detector, and we suddenly get all your numbers churned out the other way. It doesn't happen that way. We have to subsample the sample. So the sample arrives. Quite often we'll do a gamma spec on it when it arrives. It may be that it's drowned and ground before it arrives. before we do that gamma. It then gets broken up and subsampled into to various sections. We've assumed that there's volatiles on this, and therefore the gamma's been done before the breakup. So we have to put the tritone carbon-14 to a foil bag if it has to wait for a day or two before it can get onto the pyrolyzers. Chlorine-36, iodine-129, again, needs to have a separate portion taken out. Everything else, the sample's ground, and then it's subsampled again for gamma, for gross alpha beta, for digest. We gamma the subsections here to make sure that it's still representative of the whole portion as best as we can. The digest is then gammaed again, and then you're starting to go through your other analysis as stated below. So as you can see, your one sample, which started off to be maybe 5 grams of quite a large portion, suddenly becomes 1 or 2 grams for each of the nuclides that you're looking for. So how representative is those small portions to the whole thing that you're then looking at? Swabs. Oh gosh, do we see swabs. But in reality, how real is a swab? If I'm dusting at home, I'll end up with something like that. My duster has gone over the surface and it's picked up whatever the loose contamination is on the top. But if I open that duster up, you're going to end up with the same sort of effect you've got here. A lot of that is going to be in one area, and you've got a lot of blank spots going through. But that could be representative of that full wall that you're looking at. We then have to do something with it, I think is the polite way we're going to put it, and we're quite often asked to turn it into a confetti, to turn it into a more even geometry, to make it more homogeneous, and we analyse that. But it doesn't come without its problems. And even with those whole swabs, you can see the gamma ratios aren't necessarily in correlation. And Keith, please interrupt me if I get this wrong. And each of the portions in turn that are then taken out as they are gammaed are all totally different. So you could be paying a whole chunk of money for a real random generator. So it's just an honest assessment. One of the other things that we have issues with, or a lot of labs will have issues with, is asbestos. Now, the project example we have here was we were being sent some concrete pipe, which they then decided to let us know when it arrived was full of asbestos. We are not able, and most labs are not able, to actually physically prepare a sample or change the physical sample that may have asbestos in it, because our insurances won't allow us to do so. These samples ended up going back to the site for them to prepare by their asbestos workers and sending them back in a form that we were able to handle. But it is an issue worth noting that most labs' insurances will not allow them to physically prepare or change the physical form of an asbestos-contaminated sample, and you've all got a lot of asbestos on your sites. Size matters as well. We've kind of highlighted that, you know, yes, we can analyse the tiniest of portions, but calculating it back up, are you going to get your LODs that you're needing to as you can sign the waste, etc. So it really is worth noting. There's an ISO standard on limit of detection here, which I'm not going to read, you're all very capable. But again, when you're looking at ILW samples, certainly in a lab like ours, the smallest amount is what we're wanting, but it's not necessarily what's actually going to do the best job for you. And if we're using a subcontractor, of course, they've got different limits and different constraints, and therefore, you know, we need contacting as quickly as possible. Estimates, well, I did kind of joke earlier about activity levels for transport. We are finding on a lot of sites that you can times almost by 10 the activity levels that you are expecting within that sample just to consign it. And it's those activity levels we're using to then process these things through the labs. We're putting loads and loads of extra health and safety and risk assessments and everything in place to handle those samples that might not necessarily need all of that. The other thing to bear in mind, of course, is if you've got segregated labs of environmental and active, and you've 10 times an environmental sample and it's going to end up on the active side, are the results you're going to get real? Because what are the chances of that sample actually getting cross-contaminated as it goes down that active environment? So again, just worth minding. So from a lab's perspective, we like things that need the minimum amount of prep, so small pieces are always good. Make sure the sample holders are okay, make sure you've got the appropriate sort of sample holders. Make sure that if you're sending high activities that the labs are given plenty of warning. There's nothing worse than you saying, I want to send these today. Our guys say, whoa, hang on a minute, we can't receive those because of the activity levels. You're stuck with a bunch of samples you can do nothing with, and you've got a deadline in a couple of weeks. You know, we're trying to help you move forward. So really communication is key. I think one of the things I scribbled down actually as Dave Wickenden was talking was that I'm in favour of what you were saying, by the way, but really because we are cost limited. Analysis, no matter which way you look at it, is very expensive. Our reference materials, our sources, our resins are very, very expensive. And with the best will in the world, as much as we'd like to bring prices down, it's not always feasible to do so because we've got to cover our costs. We desperately need reference materials to get some of these methods properly through UCAS accreditation, etc. And we dearly want to do so. But if we can't keep the costs of those down, it means our prices are going up again. And it gets to a point where all of that is going to be passed on to yourselves. A laboratory, commercial or otherwise, is reliant on the amount of samples it gets in. And if it doesn't receive those, then it becomes the self-professing prophecy in the fact that so many times I've sat at meetings like this and they say, well, there really isn't the capability and capacity within the UK to do this. There isn't because we're not getting enough samples. And unless we get that, we can't invest, we can't do the things that you guys need us to do in order to keep up that standard, to keep up that requirement that you all need. So my final plea, apart from keep us all employed, is you know, we do need we need the support from MPL to get us moving forward. We need the support from you guys to give us the samples that we can keep maintaining the standard that you dearly want to achieve. So that's me, and my thanks do go to the two folk that did a runner at the top, and Keith, bless him, who gave me the analytical slides beforehand, and I hope I haven't bored you too much.